right, now we're going to continue what we were doing. The remaining problems are all what I would call mixture problems. Okay, so they're all going to have a very similar feel. Notice already on 6, 7, and 8 how there's kind of this box that they set up. This is really helpful. Go ahead and get a snip of those. Okay, so they've already kind of got a box set up. Okay. And we're going to do, when there's not one, we're going to do something like that. But these will have a similar feel. All right, so what's going on here? I won't try to go into gory detail, but the gist of it is you've got this one container that contains a solution, okay? So you got some container that contains a solution, like a beaker in a science class, okay? Then you got and let me make it straight up and down on the sides. It'll be a little easier. Right? So, and then you've got another container, okay, that contains a different solution, and then you're going to mix them together and pour them into another container to create your mixture. So it says how many gallons of each a 15% alcohol and a 10% alcohol solution should be mixed to obtain 5 gallons of a 12% alcohol solution. So here's what they're talking about. You don't know how much of each, but like when it's what it gives you is the concentration of alcohol in the solution. So it's mostly water with 15% alcohol, okay? And so you're going to have a certain amount of each of those, and you're going to put them together, and you're going to get this new solution. Okay, so you might have, say, that much of one of them. Maybe you have this much of the other. Actually, you're going to have more of the other one. So hold on. Let me draw it so it represents it. So you'll have this much maybe of the other one. And then you're going to pour them together. And when you do, that's going to wind up giving you, so we'll put those both together into a container. I need a little bigger container. Okay. And so I'm going to put them both in there. I'm going to have about that much. Let me try to draw it better. Okay. So I'm going to have like this much and then the other one. Okay. Both in there. Of course, they wouldn't just be separate like that. You'd wind up having something like this. Okay. But they wouldn't be separate. They'd be all mixed together. Okay. So the amount of this one is X here. The amount of this one is Y, all total. Okay. And then you're putting it together, and all total, this is going to be 5 gallons. Okay. All right, so I really want you just to kind of see the similar feel on these. First off, anytime you're dealing with percentages, like in a money problem like number 8, or an actual mixture problem like number 6, you're going to want it as a decimal. So just a reminder, 12% means divide by 100 is equal to 0.12. You move the decimal 2 places to the left. So 12% is the same as 0.12. 3% would be 0.03. Okay, so that's something we needed to know. The symbol for percent actually tells you its meaning. So 12% is 12 divided by 100. That's where the symbol comes from. Okay. All right, and when you take 12 and divide by 100, you get 0.12. So you'll notice that on all of these, that they'll put the percentage as a decimal, okay? All right, so what happens is this, the X alcohol solution is 15% alcohol. So out of all of that you see in red, only 15% of it, 15 parts out of 100 would be alcohol. So if I took the 0.15 and I multiplied by how much of the whole solution I had, that would tell me the quantity of alcohol I had. So that's going to be 0.15x. Okay. Now, the other one is 10% alcohol. It's more, the whole quantity is more, but it's only 10% alcohol. So the alcohol in this would be 0.10y. Okay. All right. And then I know my solution is supposed to be 12% alcohol, and 12% is the same as 0.12. And I want to know the gallons of pure alcohol in that. So I'm going to multiply 5 times 0.12. when I do that, I'm going to get a decimal. It's going to be 0.6. Okay. All right. So one of the things that I just did, I want to put up here, is I multiplied the gallons times the percent as a decimal, and that told me the gallons of pure alcohol. Did that all the way down that chart. Okay. All right. So what's going to happen is we're going to set up two equations. Yours will be just like this with potentially different numbers. One of them is going to come from this fact, okay, that the gallons of one solution plus the gallons of the other, those are the only two things going into making up the 5 gallons. So that's X plus Y equals 5, okay? The other fact is going to come from the amount of alcohol in each of those. So the amount of alcohol in one of the solutions plus the amount of alcohol in the other has to equal the amount of alcohol overall. Okay. All right. So that's going to be 0.15x, and maybe I'll put the 0 in front of it, plus 0.10y equals 0.6. So there are your two equations. All right. Now these equations have a decimal. So those numbers are a little weird. You might not like working with those, but they're not that bad because your calculator is designed to work with decimals. Okay. So what I would do, this would work well either way, but what you might consider doing is just multiplying getting it so one of the variables cancel out. Sorry, I'm trying to do a calculation real quick while I'm talking. All right. So what I'm going to do is I'm going to come in here. I'm just going to show you how to get started. And I might just take this first equation, and since there's a 0.15 in front of that x, I might multiply this first equation by 0.15. Since number 2 is already positive, let's just put a negative on that on the first equation. So I'm going to multiply the left side by that and the right side by that. That's what makes it okay to do. Okay. That would be your first step. And so you wind up getting the first equation becomes negative 0.15x. And you can see that it would be a negative 0.15y equals, and then 5 times 0.15 turns out to be 0.75, and it's negative 0.75. And I should put the 0 in front of it, so let me do that. Okay. And be careful when you're typing these in about where the 0 is. It's just 0.75, and it's a negative number since that's a positive times a negative. And then you're going to put it together with 15.15x plus 0.10y equals positive 0.6. And just do that calculation on your calculator. Okay. What we did was get it set up so the x's are going to cancel. So just be careful. Make sure you include the negatives when they're negative. And you're just going to add straight down and then be able to find the y. And notice in the chart that y is the 10% one. So this is the one related to the y. This is the equation related, or the blank for the one related to the x. All right, now I really want you to see how these all kind of have a similar feel, a similar setup. So here we were making a mixture. We were taking nuts and cereal and combining them to make 30 kilograms of a mixture, okay? And they're going to sell the mixture for $1.70, but the nuts are more expensive. They're $2.50 per kilogram, while the cereal is just $1 per kilogram. So you can balance things out so that you don't have to spend so much on your ingredients, okay? So the question is, so we know that the nuts sell for $2.50 a kilogram, cereal for $1 per kilogram. They've already taken care of that. That's already in the box. How much of each should be added to obtain 30 kilograms of a mix that will sell for $1.70 per bag? Okay. So anytime I'm not sure what to let my variables be, I go to what the question is. It should be how many kilograms of nuts and how many kilograms of cereal. So they've already done that. They've let X be the nuts and Y be the cereal. All right, now, did you notice that 30 kilograms is the amount of the mixture we're aiming for? So that would be 30. And then just like on the previous problem, it would make sense to multiply the number of kilograms times the cost per kilogram. So that would be 250. We don't know how many nuts at this point, but the cost would be 250 times the number of kilograms. The cost for the cereal would be $1 times the number of kilograms of cereal. And then at the last spot, I need to know how many kilograms. Oops, I thought I was on my calculator, but it was on my password. Okay, so then I need to know kilograms of the mixture. So I'm going to take 30 times 1.70. Let me say that better. I want to know the cost overall, the value overall for the mixture is going to be 51. 30 times $1.70 per kilogram. Okay, and just like on the previous one equation comes from there and one equation comes from here. So one of them comes from the true fact that the kilograms of nuts plus the kilograms of cereal equals the kilograms overall. Okay. And then the value of the nuts plus the value of the cereal would have to equal the overall value of the mixture. Okay. X and Y are on the same side. Most folks like the elimination method. So you might start off by saying, well, let me get a $2.50 in front of the X. But since this one is already positive, I'll throw a negative on that. And if I multiply the left side by something, I have to multiply the right side by something. And then once you do that, it'll be just like the previous one. You'll have two equations all lined up where the X's are going to have opposites in front of them, and you'll be able to go on and solve. And remember, nuts is where you put the X, and the kilograms of cereal is where you put the Y. So this is where you put the X, this is where you put the Y. All right, just a couple more. I just wanted you to get a taste of these. I didn't want to give you 30 problems to do. All right, notice number 8's already kind of set up for you. All right, so here we're doing a money problem. And so we have a certain amount of money invested at simple interest rates, 12% and 9%. And then we know the total annual return, that's another word for interest, from the two investments is $1,032. And we want to know how much did we invest at each rate. Okay, so this is just like before. Let me draw a little line here because that last row is pretty much like your mixture row. Okay. And so we had $95,000. Think of it as like you got an inheritance or something. Somebody left you $9,500 and you don't want to put everything in one investment in case that investment fails. So you're going to put part of it in an investment that pays 12%. So X is what we're letting be the amount invested at 12%. And we're going to let Y be the amount invested at 9%. The formal word for the amount invested is the principal. That's why they use that word principal. Okay, then the interest rate we're going to write as a decimal. So 12% is 0.12, 9% is 0.09. Take 9 and divide by 100. Okay? All right, now just like before, we're going to multiply the principal, the amount you invested, by the interest rate, and that'll tell you how much interest you earned. So that's where they got the 0.12x and the 0.09y. And then your equations are going to come from these first. The x, we know the x plus y would have to equal the 9,500. So that's the amount invested at each would have to equal the total amount, since those were our only two investments. And then the interest earned on the first investment plus the interest earned on the second one should equal the total amount of interest earned. So there's your system. And you can do different things than what I'm doing. I'm just trying to help you understand a possible starting point. If you multiplied by the left side by negative 0.12, then you'd get a negative 0.12x, and that would cancel out the bottom one. Just make sure you distribute that to both and also multiply over here by that same thing before you add the two equations together. Okay? All right, now, number 9. This is another one to put an asterisk by. I know that one was on the final exam review, so there's a good chance that that might be on the final exam. It doesn't sound like a mixture problem in the usual sense, but I really can set it up so it is. I'm going to do a box just like they did. Okay? And so in my box, I'm going to have the number of tickets. And then here I'm going to have the price per ticket. Like how much do they charge for one ticket? So this will be how many tickets all total, and this is how much they charge for one ticket. And if I multiply those two things together, I'll get the amount of money that you collect. Okay, the amount of money collected. So I'll say it that way, the amount collected. Sometimes they use the word receipts. Okay, and then they're dealing with two types of tickets, right? You got general admission, and then you have the student tickets, right? So that's what our two rows are going to be, general admission and the student tickets. So all we got to do is figure out where to put everything. Let's see if I can move this up a little bit more. And then that I'm going to have a last column. This is like, in my mind, where the mixture would go. You'll see what I mean in a minute. Okay, so there's the chart. They just didn't create that for us. So general admission tickets cost $3. That's the price per ticket. A student ticket on my problem was $2. All right, now here's what I want you to think about. Okay, 178 and the 429. Okay, 178 people paid to see a performance. We just don't know which were general admission, which were student. That 178 was the total number of tickets sold, the total number of people, and each one bought a ticket. Okay, so the total number of tickets. The $429 was the total amount collected. So it's in the totals or the mixtures area. Think of this as the totals or the mixture area. Okay. And then the question tells you what to let your X and Y be. How many of each type of ticket were sold? So we don't know this. We'll let it be X. We don't know this right now. So we'll let it to be Y. And then we'll be able to figure out how many of each were sold. So we're going to take the number of tickets times the price per ticket. That would be 3X. The number of tickets times the price per ticket here would be 2Y. So we're going to have one equation that says the number of general admission tickets plus the number of student tickets has to equal 178. And then our other equation would be related to how much money we got. We got 3X represents how much money you got from those general admission tickets. 2Y is the amount of money you got from the student tickets. And that winds up equaling 429. The total amount of money collected. Now this has a much more usual size on the left side, so it shouldn't be so hard to see what to do. I would potentially use elimination, though both would work, and maybe just multiply here by -3 since you have a +3 on the other equation. But if you do that to one side, you got to do it to the other, and then you'll be able to add those two equations together. Okay, and you'll get rid of the X's, you'll find Y, and then go back and find the other one as well. All right, I want to do the last one as well. I know this is getting long, but we just have one more question, so I want to look at it. Okay, there's one more application problem. I just thought it was a good problem, so I included it. All right, this one says a basketball team recently scored a total of 83 points on a combination of 2-point field goals, 3-point field goals, and 1-point foul shots. So let me, oops, I got to snip it first. Okay, so let me take a snip of this, and then we'll work this problem. Now this one's a little different because we have 3 items. So we have 2-point field goals. I'll say 2-point baskets. Then we have 3-point baskets. And then we have 1-point foul shots. Okay. All right, so I'm going to make a little chart here. So this will be the number of baskets. Okay, this will be the points per each type of basket. And this will be the total points for that type of basket that we earned. So for instance, if I shot 2-point baskets, I'd have 4 points. Okay. So the number of baskets, I'll write that out. Number of that type. Okay. I'll just say number. All right. So let me get my chart kind of set up, just like the other one looked. And again, if we multiply these two, it's got to equal that. All right. So let's put the information from this problem into it. So a basketball team really recently scored a total of 83 points. All right, so this is going to be my totals area. 83 points doesn't represent the actual number of 2-point, 3-point, 1-point shots. It's over here. The total points for the game was 83. They had a combination of 2-point field goals, 3-point field goals, and 1-point foul shots, and that's what we're looking for. So we'll just let each of those be like an X, a Y, and a Z. It says the team made 48 baskets. So 48 is how many baskets they made, but it was a combination of those various types of shots, with the total turning out to be 83. All right, now what's different about this question is that there's 3 variables. We haven't had that before. So we're going to need 3 equations, and one of them is going to come from right in here. Okay. Before I do that, let me put in the points per basket. So if I make a 2-point basket, I get 2 points. A 3-point basket behind the line, behind that arc, I get 3. And if I am shooting from the foul line, I get 1 point. Okay. So that means if I took 2 times X, that'll be the total points I get from the 2-point baskets. 3 times Y would be the total points from the 3-point. And similarly, 1Z would give me the total number of foul shots I made. Okay. All right. So one equation is going to come from here. One equation is going to come from here. So we know that the number of 2-point baskets plus the number of 3-point baskets plus the number of foul shots has to equal the 48 baskets they made. All right, that'll be my first equation. My second equation will be that the total points I got from my 2-point plus the total points from my 3-point shots plus the total points I got from my free throws should wind up equaling the total points in the game. But if you have 2 variables, you need 2 equations to solve it. If you have 3 variables, you're going to need 3 equations to solve it. So we need a third equation, and it doesn't come out of that chart. It comes from that extra statement up there that we haven't used yet. So we've used everything else, but this one says they made 16 more 2-pointers than foul shots. Okay, they made 16 more 2-pointers than foul shots. Okay, so if X is the number of foul shots, it's not though, sorry. If Z is the number of foul shots. So if Z is the number of foul shots, okay, they earned 16 more 2-pointers than that. Okay, so the number of 2-pointers, which is X, should equal the foul shots plus 16. This was the 2-point baskets. These were the free throws. Okay. And so the 2 points supposed to be more, right? 16 more 2-pointers than foul shots. So if I made 10 free throws, then that would mean I made 26 2-point baskets. So I just usually double check. If this turns out to be 10, then this would be 26, and then that makes sense because they made 16 more 2-pointers than free throws or foul shots. All right, so once you're sure you got that set up, I just got that from that sentence, then I'm just going to add that as the third equation on here. I also know that X equals Z plus 16. All right. So now this one's going to be interesting to you, I think, because it's got 3 variables and we haven't had that before. So one of the things you could do would be to replace these X's in these other 2 equations by Z plus 16. So see how the X's should all be the same if we have a point of intersection. And I know from the last equation that X should equal Z plus 16. So what I would recommend you do is this. Put in Z plus 16 where the X would have gone. Okay. You still have the plus Y plus the other Z equals 48. It's just where X used to be, which is right here. I put the Z plus 16. Okay, do the same on the other equation. 2, and then right here, I'm going to put the Z plus 16 in a minute. Then I have plus 3Y plus Z equals 83. So I'll put that in here. Okay. And I've used that third equation and done substitution in here and here, because then really I have 2 equations right now. So I've taken my system that started out with 3 equations and 3 unknowns, and I now just have 2 equations. And see how there's only Y's and Z's in those? Okay. So what you're going to wind up doing is kind of cleaning this up a little bit. So see if this makes sense. I'm going to take the Y. I'm going to put the Z's. They're on the same side together. That would be 2 Z's. So the Y plus 2Z. And then see that 16? Let's move it over out of the way. Then that would have to equal 32. Now your numbers will be different, but you'll have something similar. This one's got a little more work involved because I had that 2 out in front of the X, so I have to distribute first. So let me do that right below here. This would be 2Z plus 32 plus 3Y plus a Z. And notice I'm putting that little extra mark on my Z's so I don't get it mixed up with my 2's, equals 83. So then I'm going to clean this up a little bit and see how I have a 2Z and a Z. That's going to be 3Z. See how I have a 3Y? That's going to go right here. And then can't I subtract that 32? Let me do it in red so you can see it. Subtract that 32 from both sides. So that would become 51 on that right-hand side. Okay. And there's your 2 equations now. So you took your original 3 equations with 3 unknowns and we did a little substituting for the same variable. And now we're working with 2 equations and 2 unknowns. We got it down to a reasonable amount. So now your next step might be to maybe take this equation and multiply by -3. Take this and multiply by -3. Can you see why I chose that? The -3y and the positive 3y would cancel out when I add. So I would use elimination at that point. Okay. So what I wanted, my goal for this video was to help you set up the mixture problems 6 through 10. Your homework assignment in my math lab on this will have these same problems, but you'll just potentially have different numbers and you just have to finish getting those solved. Okay. So once you feel better, once you've got the basic solving process down, that's when you'll go in and work on the applications. Okay. They work the same way, but the numbers are just a little larger. Okay.